Today's lecture is on the layers and tiers. Layers and tiers are the hierarchical software architecture patterns and mostly used patterns. So, layers are a complete decomposition of a given system or partitioning of the whole decomposed system into different layers, such that each layer has a unique characteristics and functions. Why we need layers? Why we cannot implement the whole system in a one unit? The question is that sometimes implementation of a whole program as a one unit become difficult because there are so many things involved that makes it difficult to implement that system as a whole one unit. And we go to the layers such that each layer has a certain programs. Each layer can contain one program or many programs. And the purpose of all the program is, the goal of all the program is one. So for achieving a particular one goal aim, all the programs installed on particular layer work for a single purpose. And then the layer communicate with other layers. This means each layer will have a definite goal. A layer is a set of subsystems or programs which are able to provide a related services that can be realized by using services from other layers. We have two basic types of layers. One is called closed layer and another is called open layer. In closed layer architecture, the ith layer can only have access to I-1 layer, means the below layer. The layer will access only the previous or below layer, and the advantage is that high maintainability and portability, because there is a less integration issues, so maintenance become easier. We have example for this architecture, closed architecture, is a OSI, open system interconnection, which is a networking model and which will be discussed in detail in this lecture, where one layer is connected to other layer, not with all. You can see here the closed architecture. Here we have four layers. For example, this is layer 1, layer 2, layer 3, layer 4. Layer 1 is connected to layer 2, layer 2 is connected to layer 3, and layer 3 is connected to layer 4. And in open architecture, the ith layer can have access to all underlying layers, not previous and the below layer, but with all layers. And the advantage is to increase the efficiency, decrease the execution time, increase the performance. But integration and maintainability become difficult. Testing also become difficult. So closed architecture is easier to test as compared to open architecture. Here you can see layer 1 approach both layer 3 and layer 4, and layer 1 approach layer 3, layer 2 approach layer 4. So there is no restriction. One layer can approach many layers. Now come to discuss, this was all about the layers. Now come to discuss the layered architecture, layered software architecture. It consists of order set of layers such that each layer providing a service to a layer above or getting from below. This means the layer will get service from the neighbor layer and will provide the service to the other neighbor layer. The neighbor can be up or down. Each layer has two interfaces, the up interface and the low interface. Examples include the package, libraries or header files. When we write a programming code in a certain tool, we call some libraries. For example, for variable declaration, for output, for table creation in the form, GUI form, for text, for passing values to text fields, and for so many activities, we have a certain libraries. So we define it. And when the program executes, the library is called. Libraries or header files are called and are executed in layer-based approach. The components of layer architecture are the programs or subprograms deployed in each layer. So inside layer, we have programs and subprograms. Connectors. Connectors examples are protocols. The protocol is defined as a set of instructions which guides what to do. So here protocol guides about the service creation, service communication, procedure call or system calls. This is the figure. You can see client connect to the system with a user interface, particular user interface, and then instruction is passed. The input instruction are passed as a business process. Based on some business process, the instructions are passed, and actually the business process is the instructions. So this is the user interface, and business process handle all the instructions, and basic utilities and libraries are called, and then core services are handled. And when the core services are handled and executed, so from this layer the services are approached here and then passed to the user through interface. This is a generic example. So this is a layer I minus 1, I minus 2, I minus 3. This is a specific example. When client connect to the computer and we have activated the firewall. So firewall comes on this second down layer. For example, if this is the ith layer, this will be I minus 1 layer. If this is the 1, 2, 3, 4, 5, this is the 6th layer, this will be the 5th layer. Proxy, all the proxies are activated in 4th layer. And we have a web server, and this layer is also called presentation layer. The data is presented. Web server pass this data to this layer, which is called business layer. Business layer include both application server and backend program. So different programs, data access program, collaboration, business logic, workflow, personalization, connectors are here. And this is the data layer, where data is passed to the data store. Pair layer hierarchy. Each layer only provides service to the adjacent upper layer and only requests services from the adjacent layer directly below. This is the pair layer. This means the closed architecture is the pair layer approach. Special cases may employ a bridge type connection, where an upper layer gets service from a layer more than one, and this is also called a closed architecture, or bridge type connection is there. A simple software system may consist of two layers: interaction layer and processing layer. The interaction layer provides user interface to the clients, takes requests from the clients, validates, forward requests to the processing layer for processing, and respond to the clients. And then processing layer is responsible for receiving the forward request from upper layer, perform the business logic process, access the database, return the results to its upper layer, and lets the upper layer respond to the client, since the upper layer has a GUI interface. So this is the simple layer based architecture. Remember that for layer based architecture, two layers are necessary. Minimum requirement is that we must have two layers. If system has one layer, we cannot say it as a layer architecture. So the simple architecture must have, the simple layer based architecture must have interaction layer, where user interact with the system through graphical user interface, and processing layer, which process the user request, etc. Java virtual machine and layer architecture. So the Java virtual machine is also implemented on the layer based architecture. Here we have a Java application installed, libraries are installed, operating system and a processor, and we have this system, and operating system is installed on the system, processor is inside the system, and virtual machine is installed. So we have two layers on the this side. First is application, Java application, and second is virtual machine is installed. So this is a good example of layer based architecture. This is another example of OSI model. We have 7 layers here: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Each layer has a unique responsibility, and data pass from application to presentation, from presentation to session layer, session to transport, network layer, data link layer, and physical, and each layer has a set of unique characteristics and protocols. Applicable domains of layer architecture: any system that can be divided between application specific portion and platform specific portion, application that have a number of classes that are closely related to each other so that they can be grouped together into package to provide service to others. So any application that has a number of classes can be based on the layer architecture. but use this style when the order of computation is fixed. Interfaces are specific. Components can make no useful progress while awaiting the results of requests to other components. Benefits include incremental software development based on increasing levels of abstraction. So we can deploy a software in increment using the layer. Enhanced independence of upper layer to lower. So each layer is different, and we can easily replace one layer. If there is some problem or we want to update some layer, we can easily replace one layer. So this means it will enhance the flexibility. Interchangeability and reusability are favored. Component based technology is suitable technology to implement layer architecture. Promotion of portability. Limitation include lower runtime performance overhead because of the data marshalling and buffering by each layer. So when data is passed from one layer to another, obviously it takes some time, the program are executed, and due to the increasing program execution time, the total execution time of layer, and thus the whole system can increase. Many applications cannot fit this architecture design. Interlayer communication may cause deadlocks, and bridging may cause tight coupling. So coupling is a big problem in every hierarchical architecture. Exceptions and error handling arises in the layer architecture. So when exception arises, remember that if there come problem in one layer, so other layer is wait for neighbor layer. So this means the neighbor layers are also affected. So exception and error handling can also be an issue. This is another example. If we take VB.NET, C#.NET, and all the .NET platforms, so they all use the intermediate language. Every language tool has a specific programming syntax, writing style, but the libraries are common. The libraries for all the tools are common. So they all approach the same intermediate language code libraries. And then CLR, which is another level. CLR is a common language runtime, is an environment that manage code execution and provide application development services. So this layer is approached, but for this layer is important. Why? If we skip this layer, so as each tool has a unique characteristic and coding style, so it will be impossible for all the tools for execution. So the interpreter converts the code style to the intermediate language, which is a common language, and then common language is executed here, and then we have operating system, and then the code is converted to the machine learning by the operating system. If we take only one, for example VB.NET, so again intermediate language come here, libraries are here, and then syntax are defined and converted based on the interpreter and compiler. What is virtualization? Virtualization is another property that is used in the layer-based approach. Virtualization is defined as the abstraction of objects, creating a virtual version of objects such as server or storage device. Example include the hard drive partitioning. Remember that memory is same, the physical storage is same, but virtually we create objects. or storage devices. Like if we take hard drive partitions, such that each partition looks like as a separate portion of hardware, represent a separate portion of hardware, but physically both drives are combined. Virtualization is a technology to run multiple same or different operating systems which are completely isolated from each other. For example, run both Windows and Linux on the same machine. For that, we install a virtual machine, and then multiple Windows operating system can be installed, and virtual RAM and memory is assigned to each operating system. So types include server virtualization, desktop virtualization, storage virtualization, etc. So we can apply virtualization for the storage devices, desktop can be shared virtually, and server virtualization. Virtual machine system models. Virtual machine or VM is a software implementation of machine that execute program like a physical machine. Example include emulation software. It share a physical hardware resources with each users, but isolate the operating system and application to avoid changing the end user experience. So you can see hardware is same, and here we have a virtual machine manager and virtual machines are installed, and then we have a separate processing kernels. So this means either operating system are distributed, we have different operating system installed, or there is a virtualization. This is a non-virtual machine which has only one hardware, one operating system kernel, and one process. Here process is distributed virtually. So you can see here layer-based approach is adopted. So these are the different layers you can see. So we have different application installed for different users, which include the Windows XP, Windows NT, and other window, virtual CPU here, virtual memory, virtual devices. So each virtual application consists of virtual CPU, memory, and other devices. This is virtualization layer where virtually services are provided, and then we have a host operating system. Remember that we need a host operating system. For example, if we have a host operating system Windows 10, so on Windows 10 we can install Linux, Windows 7, Windows XP, so Ubuntu. So we need a one host operating system, and then on the upper layer we have a virtual machine installed, and then the virtual machine provide a unique characteristics. And we have a one hardware layer. Processor is one, memory is one, physical hardware is one. We have a host operating system, and on this layer we have virtualized program, and then we have a different application. So if we want to increase the number of application, we can easily do that. So this is the hierarchical representation of Java virtual machine in a layer based. So this is a Java source code which is written in a Java platform. We have a Java compiler which compile the Java source code and convert it to the Java bytecode. So we have JVM, Java virtual machine for Unix, and Java virtual machine for the Windows. Java virtual machine for Windows work on the Windows operating system, and for Unix we have a Unix operating system. Java virtual machine is an abstract machine that enables your computer to run a Java program. So what is JVM? JVM is a abstract machine that enables your computer to run. So for Java we need a JVM machine. When you run a Java program, Java compiler first compiles your Java code to a bytecode, then JVM translate bytecode into native machine language or hardware language. So what is a bytecode? Bytecode in a Java is a set of instructions for Java virtual machine. Bytecode is a platform independent code. This means bytecode does not depend on any specific platform. Bytecode is a code that lies between a lower level language and a high level language. So we can see this is a high level language and this is we have a low level machine language. So compiler converts this high level language to a Java bytecode. After a Java code is compiled, the bytecode gets generated, which can be executed on any machine using JVM. So if we have a Unix installed, or on other side we have Windows operating system, so the Java bytecode then run on the both machines. So before the Java code, we must have a compiler, and compiler converts the Java code to the Java bytecode. So again we have a layer based approach here. Virtual machine architecture has some benefits like portability and machine platform. We can easily make a system portable on different platforms. Simplicity of software development, simulation for disaster working model, and limitation include slow execution of interpreter due to interpreter nature, additional overhead due to a new layer. So these are the limitation. Now come to discuss the another approach, which is a tier which work in the layers. But remember that mostly we make a physical separation in a tiers, while layer based approach, in layer based approach the separation is mostly logical. So physically we can install different layers as a tier. We have a 3-tier, 2-tier application available. 3-tier means that the software will work in the 3 layers, 3 physical layers. Like web, we take example of web application. So we design a web page in HTML, CSS, JavaScript. That is the 1 tier, front tier. Then we have a middle tier where a programming tool works and the business application process occur. And then on the lower tier we have a database which is installed on the server. So data goes to the 3rd layer using the 1st layer, and intermediate layer functionality is to process the data from input, process it, and also show the output to the upper layer. So presentation layer, presentation tier, logic tier, and data tier. So presentation tier is a topmost level of application, is a user interface. The main function of interface is to translate the task and results to something the user can understand. This means we design our interfaces in presentation tier. For this we need separate tool for this. So 3 different tools are involved. If we don't like this interface, we can easily develop in some other tool. So the physical separation, reusability become, modifiability become more easier. Logical tier, this layer coordinates the application, process commands from the user, makes a logical decisions and evaluation, and perform calculation. It also moves and processes the data between the 2 surrounding layers. And we have the data tier. Here information is stored and retrieved from the database or file system. The information is then passed back to the logic tier for processing, and then eventually back to the user. So this was all about the layer based architecture. So hopefully you understood. Thank you so much for watching my video. Thank you so much.